our simulated agent, in this case, will be Francisco, our founder and CEO. He will go through our platform and show you how to build a search engine with our platform as a shared memory pool for the agents. Okay? So let me try to get a feeling for the room. So how many of you trust LLMs? Don't be shy. You do trust your LLMs. So you feel that they are truthful all of the time. Is that right? Okay, thank you. That's what we're going for. So would you trust your data engineer as an LLM if it lies to you over 10% of the times? Okay.
Fire the person.
I would as well, thank you. So this is what we are trying to solve, okay? To bring the context and the knowledge into your AI so that it doesn't lie, or at least it lies much less than currently do. So let's see. Maybe you know this problem, okay? And maybe you have an answer for it. Come on, it's an orchestra. It takes 120 players during 40 minutes to play the symphony. So if you have 60, how much time it will take?
It's a good math problem. By the way, we're using this a little bit as an icebreaker, but
it's still 40 minutes. Thank you. Someone is a musician over there.
Let me show you
goes to it. So, Francisco, can you show us how an LLM deals with this problem?
So I'm going to run this on a DeepSeek. I assume everybody knows Llama. It's pretty much an easy way to run LLMs locally. What I'm going to do is I'm going to copy this, and I'm going to paste it into DeepSeek locally. And one of the interesting aspects here is that the fact that we're giving it the context of I have a math problem for you kind of throws DeepSeek into assuming that it is a math problem. We tried some of these ones when we were doing a stand-up, and with the next one, we actually got DeepSeek to build a whole half-an-hour-long answers about how deep was.
Yeah, it built a thesis, a wrong one, but it built a thesis around it.
Yes. But pretty much you can see already that for the answers that DeepSeek is taking on the bottom, that it's already approaching it as a pure math problem. And it just, if we run this, right now, if we run this on the newer LLMs, because this question has been on the web for a while, you start guessing some of the newer versions to answer this correctly, because they got trained with it already.
Yeah. So yeah, you probably know how LLM training works. So they get these problems into the reinforcement learning data sets. So they train the model to recognize the problem and to reason about it. So why don't you try the next one? Okay. Yep. You probably have heard of this problem before. Okay. What I will ask to you is read carefully the context that we are giving to the problem. Okay. If you see there, we have made a little naughty change into the statement. Yeah. So the boat now can carry a farmer and two animals. So how many trips do we need to cross everyone to the other side? By a raise of hands, of fingers in this case, how many trips do you think are necessary? We have a very shy answer there for 6. So yeah.
We had the one as well over there.
You have the one over there. I didn't see that one. Yeah. So someone knows how to read.
Yeah, the
properly.
correct question is 1. So far, we haven't found still one LLM that can answer this question. Mainly because they've been so trained into this being a classical problem that all of them answer 3, 4, and 5 all the time. And you can try with the bigger ones, small ones. And one of the problems that we're seeing with agent collaboration and agent execution is how do you actually route them all into the same source of truth that they can actually pick data that connects itself to answers with high accuracy. That's what we're going to show you guys in a second, but I'm not going to let DeepSeek run through this because once we had DeepSeek think about this for 15 minutes. So
yeah, and it started adding new artifacts, and even a pineapple showed up in there. It was a crazy answer. So the key here, and I think we can back Francisco, the key here is that the context is very important, and it is the context that allows us to have proper multi-agent systems. Yeah? So we have already in our platform a series of agents that extract data from the web and interconnect this data amongst each other. right, at the cell level. So each value can be connected into and take you into a different data set. And with that as well, we have built already a search engine, verticalized search engine called tariff search, right, to tap into the tariffs data. What we'll do now is Francisco will kindly simulate that he is an agent, and he will build this search engine by himself in something like 20 minutes or so, right? To show you how you can do something very close to our search tariff.
So what we're going to be doing more concretely.
No, yeah, thanks.
Yes. Okay. So what we're going to be doing more concretely is the following. Search tariff is actually, we've been building a platform that enables you to dump data into it, and it automatically connects itself together. With all the tariff work that happened, like since the beginning of the month or early last month with the Trump tariffs and the whole escalation of the trade war, we decided to actually implement an agent that goes through the web and gets all the tariffs at product granularity level. And we've released this website in a weekend on that pretty much enables free text search on top of a tariffs data asset that lives within the DataLinks platform. So if you go here and, for example, search for tariffs on cherries from Europe to the US, you'll find the tariffs that come. Wait. I'll try this.
As you see here, we have implemented natural language search on top of a query language, a native query language that we developed for our platform. Because this is one of the things that we've noticed. There is an open problem about generating SQL in order to access data. And it's still an open problem. It has been solved. LLMs are not that good generating SQL. So we built our own native language that is made to play nicely with large language models. It mimics English so that we can generate queries with something like 99.9% of accuracy.
So pretty much, wait, this is way louder.
You're now mic.
Yeah. So part of this search engine pretty much takes natural language queries and translates it into data link queries. This then pretty much is now helping people and organizations navigate the tariffs use case. One of the interesting aspects that happened was that we shown this to one of our customers, which is a stock exchange, and they immediately wanted to map out tariff impact at ETF and index level. If you guys want to reach out to the SIX group or Ultimus to get access to that data. What we're going to be doing now, I'm going to run with you guys how to do a mini version of the agent that they built to actually build the simulation on top of DataLinks. So if we go here, we can see the same data asset that we were just searching on the other website. That includes all the tariffs. We can run queries on the bottom. And what we're going to do is we're going to pick up a small subset of data. And here, what we have is pretty much a small prompt. Me being an agent, I'm going to be using prompts that pretty much has a snapshot of companies that are from SP 500. It has a small schema that says, let's build a company, a ticker, and the product, and some products that were pre-matched against these, so that, and we're going to ask an LLM to build me a mapping between these companies and products on their supply chain. So if we go here, this time let me use another one. I'm going to use Gemma. 12B. The reason for 12B is just that trying to be soft on the laptop, also making faster. We paste this prompt. It's going to give us an SCV with mapping of tariffs to the companies that exist there. So I'm just going to paste it. And afterwards, what we're going to do is we're going to pick up this data set. We're going to create a new data set within the platform. We're going to ingest it, and we're going to see the platform automatically connecting this data to the data that the other agent created on the tariffs. And what we're doing afterwards is we're going to deploy a search engine on top with natural language query, because what we've noticed is that by having a highly accurate natural language transition between natural language to DataLinks queries, it actually enables to create a user experience that agents can actually start generating highly accurate questions with the speed they need to actually be able to one dump data on one side, the other one dumps data on the other. Then another one, without knowing what data is there, can actually generate now queries that discover the data and traverse, which is pretty fun. Let me show you. So if we go here, we can copy.
One question. So I know that Neo4j did a lot of this hyperquery generation. You guys, I think that's probably not your approach. You have your own language. What is a language in this context?
I'll show you.
Okay.
Yeah.
I'll show you in a second. So here, for example, we can create a new data set. Let's give it in the in the workshop namespace. Let's call it companies. And what I'm doing here is I'm going to create a new data set.
Of course, you are looking into our platform, okay, our UI. Of course, this can all be done through our REST API or through our Python SDK.
Yeah, we have an SDK online that for developers that can build quickly. So here I created this companies2 dataset just now. I'm going to upload it. And the interesting aspect, if you want to get agent collaboration, is that a lot of the data that the agents push needs to be solved or mapped to all the other data that is available in somewhat of real-time capacity. Not necessarily sub 1 second speeds, but in 1 or 2 seconds. Here what we see is that the data got uploaded. And we can see that this already started mapping. It connected data against the previous dataset that we did a dry run for the workshop. And it also connected here against the tariffs dataset. What I'm going to do now is actually I'm going to remove all of this because we don't care about these ones. And I'm going to keep the connection between tariffs. So you're asking about what is the syntax. So what we're building is a platform that connects data, but instead of thinking Neo4j graphs or normal graphs where you have nodes and you have arrows connecting the nodes and you need to define what those links are. Here we do them automatic. For example, here the type of link that got detected is an exact match, but we have other types of links that generate different types of entity resolution. Some of them are geo-based, some of them are fuzzy links, some of them are numeric overlaps, windows, and so on. So the question is, we put the data into it, and then you link it together, and then maybe you do embeddings or vector on top. We actually look at embeddings and vector as nothing more than another type of entity resolution that is a similarity scored entity resolution type. And it just activates as part of the many entity resolutions. Here for this demo, we're actually just keeping the exact match just for speed and to make sure that the demo is stable in conference settings. But pretty much what happens is that afterwards, because these are tables, we can actually come here and we have a small data explorer, same data that we had before. And this is, when we're talking about tabular knowledge maps, we're talking about, instead of thinking about nodes that are loose in the web, we're talking about concrete tables that are connected at cellular level or multi-cell level. So here, for example, if we come here and you search, for example, for cherries, let me find, well, let's just go with palm oil, it also works. And we do a search around, we actually now land on the tariffs data for the tariffs that are for search round, for the tariffs that are for palm oil. You can find this one here. It actually matched a bunch of oils in between. Let's go with steel. So here, for example, okay, you can find here multiple tariffs on steel, but the context is that if you now pick up the results that you have here, we also have a scoring mechanism that can be fed into the results. You can pick up the final table, and if you pass this final table back into an agent, the agent is now executing with full context without knowing that the data on the other side even existed. The queries that you're asking what they are is pretty much this query here. And this query, we built it in a way to try to be as neutral as possible from a programming language standpoint. Meaning, as long as you have the API implemented, this can pretty much go into almost any single language. And the thesis that we had there was, if you want to do fast query generation to actually be able to expose a public website on the web for users to use, you kind of need to run these things on small language models, and you cannot have long reasoning steps. So how about let's try to piggyback on the training that LLMs have of all the languages at once, and also the training that they have of English itself. And we ended up with this query language.
Yeah. The funny thing about this is that we've tried with different prompts, of course, and in order to get the full 99.9% accuracy, we actually get the primitives into the prompt. But if you don't give the primitives, it still pretty much works most of the time, even without the primitives of the query language, which is kind of a funny fact about it.
Yeah. And then from an agent collaboration point of view, we support and search rounds, we support deep graph search where you can go, imagine here tariffs is actually connected directly to the companies. But if they're connected with a depth of maybe 5 or 6, we could actually, it just ends up doing a broad search and finding if it doesn't find on the first level, it can go to the second level, then third level. It's also, by default, it only goes one level down, but we could have written here on the search round saying max depth 10. And then it's a bit explosive on the memory, but we handle it on our side, and it just goes all the way down.
Yeah. And as a plus, you get the lineage of where you get the data from. So not only are you bringing the context, but you know why you are bringing that context.
Because each one of these steps that you end up having, you can actually track it for lineage. Again, inject it into the agent. The agent has full context exactly where the data went from, or it came from, which means starts enriching the prompt a lot. So here in this quick example, for example, if you now pass these results to a second agent that calculates tariff exposure scores, you end up with having a risk factor for the company that we just did a search round. If you do this in bulk for all the products that they have, you end up with full scoring of tariff exposure for example, in this case, SP500 ETF companies. If anybody is interested on that data, by the way, hit me later, because we did a partnership with Ultimus, which is a company from the Swiss Stock Exchange, where they're actually now publishing this for all the ETFs that they have access to. So let's now build a quick search engine on top of this. We actually have this website out, which is a search engine NLP starter. Originally, we were planning this workshop to be, let's just give access to people, but since folks were not coming with computers, not everybody, we decided to just run. If anybody wants access, hit us afterwards. We're happy to give, and you can actually try this yourself. You can come here, you can clone this repo. From this repo, we can go and you just need to pick up this env example, put your token here, put the data set that we want. In this case, we just created a data set called workshop companies. So just got to copy that. And then let me kill this LLM. We're in workshop data console. And then here. Now, if I go to, where is it? I'm just going to replace this one here. We do have full token support on the API requests, by the way. This token is set to expire tomorrow, so I'm not very worried about it. But we can go, we can run this. It's the same project that is on that GitHub repo. And by just checking out that project, we pretty much end up now with a full search engine on top, where I can actually search for what data do you have here. We had, for example, steel tubes. Okay, sure. Companies. And this translates into a natural language query on the back and gives us an answer. If we then afterwards want, we can go and actually do a search round and say tariffs on steel tubes. And this, what he's going to do now, he's going to go into the companies themselves, do the search round, land on the next one.
The big question, how does this scale? Because, usually with graphs, things get difficult with large volumes of data. So how are you guys solving these issues, or are you facing any scalability?
Yeah, we're not very afraid of it, to be honest. There's a couple of things here. One, we're not making pure graphs on the sense of being cellular. We're doing them tabular, meaning that you can piggyback on all the techniques that are database techniques for tabular data structures. So it's quite easy to have scalability on that end. The interesting aspect is afterwards, how do you actually keep the scalability on the indexes in between? And what we're doing there is that we actually own the indexes. It's part of our tech and lives in our servers. And the fact that we own both the indexing and the query generation means that we can have shards that are at index level. We can just parallelize as needed. We have some of them in auto-scaling mechanisms if they're needed. But in the end, same techniques that you find on normal tabular databases, but now applied to entity resolution that happens at cell or multi-cell level.
Were you using anything like iceberg?
No, we built most of it ourselves. And with that, we had aimed this to be roughly half an hour talk. We did 25 minutes because I think I spoke too quickly, but that is pretty much the gist. But this is pretty cool because it is building a medium that is enabling us to have multiple agents that just dump data into the same place. And then at most we can feed the schemas of the tables, but does enable them to start very quickly doing search arounds that are multiple depths in and so on. Then for use cases, the tariff is one that we very quickly deployed, but we're seeing some other clients starting to experiment with multi-agent collaboration in other places, but it takes time. We're a 10-month-old company, so we're building. If anybody wants access, we had put ourselves as a hard deadline for today to give access to people. We still approve folks individually, but if anybody wants to play with the platform, just hit us. We'll happily approve the users.
Yeah, by the way, those tokens are used not only for control access, but also to access to the data control. So if you put your data as private, only your token can access that data, of course. And if you see here, you could easily also build an AutoRAG system using our platform as a basis. You don't need to because we are putting that agent out for you, the agent that does the AutoRAG. But you can see how this can be split into several steps and each one fetching the correct data for your agent. Okay? So stay tuned. We'll release it soon enough.
Yeah.
Is it Q&A? I was waiting for the end.
Yeah, you can ask questions. Yes.
Yeah, go ahead.
So we're just going into Q&A, right?
Yes.
Yeah, we can assume that.
It's official now with a microphone. So I totally understand what you're doing, your approach. I'm just curious. One of the challenges with exact matching and say regular expressions, and then fuzzy matching and creating like a hierarchy of different algorithms that you like to use, is that you know what's right, and when you've got unique keywords or entities for a certain industry, that works well. Mm-hmm. How do you decide when to make that switch from from a scaling perspective, where an exact match on a word that's not particularly unique, but it's chosen at first based on your levels? How are you managing that problem? Because I can see myself building something like this at a custom level because I know the data set and I know when to use exact match, Levenstein, Giara Winkler, what have you. But as I go further down that chain, I struggle to let go. And that's ultimately what I'm looking for in AI, is like, when do I feel comfortable letting go and having someone else work fast?
I'll make the problem even harder.
Oh, yeah.
Which is, if you're indexing a 1 or 2 gigabyte data set, and you're doing automated entity resolution, and let's use just exact match because it's very easy to visualize. It already starts looking like this, for context. If I go on tariffs, because we do enable loops, and you see here, like this is, we have thousands of hits, we have multiple columns matching to different columns. Here, for this workshop, we're actually running this on a small volume of data set. You don't see the other data our clients have. We publish other pieces of data, not just tariffs, but also corporate registry, Edgar data, sanctions, etc. Just enriches the knowledge map. But it also means that at some points in some data sets, we often see 50,000 links. So part of the secret there is we actually have an agent on the back that looks at snapshots of data and pre-selects those links for you. Which lowers otherwise it completely overwhelms a human configuring this. And
like an agent kind of seeing what links matter.
Exactly.
And then you have an agent perhaps choosing what is the most appropriate
exactly.
method based on the type of the word that it recognizes being unique or right now.
Yeah. And the links are permission aware, meaning that you only see the links to the data sets that you have access. For example, in this case, we're using my account that I cleaned before this, and I right now don't have access to anything else. Otherwise, you would see immediately more links popping up. The thing is that the agents that are running need to also be permission aware, because otherwise you need to respect the data governance of different companies or different groups, etc. It's quite important, or even within individual teams. But the interesting aspect is that literally, if you look at the scheme of the tables, you can already do some predictions of which entity resolutions are valid or not. Same way that a human would do. But then if you go one step further and actually take a snapshot of the things that got matched, like an example of the rows, again, this becomes very similar to what a human would do. You can actually compare and say if these are meaningful or not. And many of them are obviously not. You can just trim them away immediately. Many of them are garbage. For example, if you're doing numeric matching, you may have different IDs that are completely disassociated matching together. You shouldn't even be showing that to the user. You can just dump those as well. So those are part of the automation that runs behind the whole technology.
Yeah. Again, I think in a sense we are borrowing some concepts from databases like entity linking and entity typing, and we are just automating it through several agents that collaborate with each other.
More questions?
Thanks for the great talk. Thanks for the great workshop. So I'm just curious, following up on Vasily kind of questions. So you create these links. Do they like? It sounds like you materialize them as rows in some link table, linking, right? Linking some tables. Yeah. So effectively you materialize a graph in a way, right? Mm-hmm. So your graph basically has your edges are rows in some table, right? And I mean, I'm from Neo4j, I can help asking, right? Like if you want to traverse a long graph, a bunch of joins will explode eventually. So why not just use a graph database? What's the advantage of having a bunch of tables?
Because business data is tabular in nature, like Excel runs the world. And the reality is that you go to any large enterprise or even small company, and what you're going to find is tabular data. Meaning that there is, for example, the folks behind Neo4j, I really admire the work that they've done, because it's hard. But I also think that the path that they've taken, both with the language cipher and the fact that graphs are still seen as nodes, is probably one of the biggest problems in graph adoption in the world, because it's just so hard to reason about it, that you, as a developer, you land in the enterprise or in the company or whatever, and someone tells you, this can be solved with GraphRAG, or this can be solved with graphs, go for it, build a graph. The cognitive step between picking up those tables and doing the data modeling to actually build it, often becomes an impediment for it. And then looking at most of the graph languages like Cypher, it's so much harder to query than any other languages that are on the market. The moment you start throwing arrows inside the expression, for example, to me starts breaking a lot of the development flows for many devs. So we just thought, look, if tables are there by default, let's just treat the whole thing as tables and actually connect the cells. How cool would it be if you go to an Excel sheet and you have one row and you click on that row or in the cell inside the row and you say, find me all the other tables and all the other objects that are associated with the cell, right? You pretty much, and then if you go one step further and you can do a deep and depth and you can do aggregations on top, suddenly you end up in this environment that you can just dump data and actually have automated traversals and agents doing stuff. It becomes pretty cool. That's the... Anybody else actually enjoy these questions, so please.
Thanks for the talk. For the exact match, what data structures are you using underneath? Are you using like an inverted index? Are you using embeddings only? Like, how are you facilitating the actual search?
So exact match is easy because you put the whole thing on a hash table and it works. Undistributed.
But what if it's a large payload of free text and you need to find an exact match within it?
So it depends.
Like a phrase search, for example.
So it depends. We keep each one of the indexes separate. For example, index for exact match at cell-to-cell level, it can mean the whole cell matching. If you mean exact match at one cell matching partial of another cell, then it becomes more closer to embedding matching. And that's a separate index. Right? That's why us running our own indexes and actually have these being disassociated from the tables themselves enable us to add indexing time to parallelize it and put the things on the correct place. And it enables us afterwards at query time to actually go to the correct indexes, find what are the next step of search around and exploration, join them back again. We have a table again that joins the whole things together. Sometimes the schemas don't match, so you end up with having some holes in the data, but the columns that are the same schema, they do match. But if the columns that have the same schema, you can actually do aggregations on top of them, which becomes to do some pretty fun activities. But for the context of the schemas, we just keep, the indexes, we just keep different indexes for different types. And then as you're searching, we choose the correct ones. It is explosive because if you have too many different index types, it can become very large. So what we've been doing, we don't have anything in the UI right now to configure it, but we have under the hood, is allowing data sets to be discoverable for different types of entities. A simple example is latitude and longitude, where you may want your index to be geo-discoverable. Imagine, for example, that you have satellite data. Okay, and satellite data has, for example, measurement readings for CO2 on a particular region or nitrogen outputs or whatever, and you're a company doing a use case around measuring your environmental impact performance on top of the factories that you have. Maybe you want to go to NASA satellites or European Space Agency satellites, but how do you even know that those satellites have the data for the geospaces that you have? If we pick up data from NASA or from the European Space Agency, put it on the platform, it has latitudes and longitudes for each one of the satellites. Now, that is very good to be geo-discoverable. Now you put some other data that, for example, a table of the factories that you have. And you do some reverse geo and you put latitudes and longitudes there as well. You may want them to discover other data, but you may want them to not be discoverable to your other things because you really don't care other folks discovering where your factories are, even within your company. Just because it's not useful, not because of privacy or whatever. Meaning that we've been starting to add the capacity to activate and disable the discoverability depending on the link type, to try to avoid this explosiveness of the different link types that we have. Right now, we're still doing it manually, but the plan that we've been discussing is just also put a very small fast agent there that actually, depending on the queries that are there, thank you. He was ordering 5 minutes. Depending on the queries that are there, we can actually swap them depending on what the person is actually searching for or what the other agent wants to do. We really want to tackle this part of cross-agent collaboration because it's hard. It requires someone to build a platform like we're building, which I believe if it's not us, someone will do it eventually. But doing this shared memory pool where people and agents can just dump data, these indexes build, they get selected automatically, allow for automated traversals, does end up creating like a master brain that you can have different agents, different LLMs consuming and dumping data. That's a general long vision kind of context. And we are publishing data. For example, some of our customers, what they've been benefiting is we do have agents that collect data. For example, go through Edgar or go to corporate registry, company house in UK, etc., and start building corporate registries. And one of our customers in financial institute area started using that to do KYB use cases, because then it connected with sanctions, and if you start doing n-depth traversal of companies, shareholders, you eventually land on sanctioned entities. And once that data was there, they could connect it with the companies they cared about for KYB, and suddenly they could do scoring of KYB, KYC workflow. So the more data you put, the more it compounds, and then not only humans, but AI systems, everybody kind of benefits from it. The tricky aspect is how do you make sure that you keep high-level granular data access to the data, because the more data there is there, the more the data permissions matter as well. Because the links need to be permission-aware, the agents need to be permission-aware. It's actually pretty tricky to handle on the back. We've been enjoying it, but it's fun. Yeah. We have 2 more minutes if anybody has any other question. Yeah?
Does it work with all of Mozart's works, or is it just...
Yeah. Yeah.
When you want to link in these, can you link them more than like one column to another column, or can you link them like, the description and
yeah, multi-column connections also exist. If you want a concrete example, if you look at aviation and you have landings and departures, you may have a maintenance event in the middle,
Sorry?
You may have some sort of event in the middle of your departure and your landing, for example, in a flight, right? The flight departs and then lands. And imagine that the toilet broke in the middle of the airplane and that gets logged somewhere. But in a separate database. How do you connect them together? That's actually a multi-column match. So you have two columns that are the departure and landing. It has timestamps. And you have another timestamp, which is the log of the the toilet getting broken. And that's a multi-column entity resolution, which is numeric overlaps. Yeah.
Yeah. Or a multi-column search.
Yeah. Or multi-column search as well. Cool. I think we're at time.
Yeah. What time? Thank you very much for the great presentation.
Thank you.
Thank you.
Thank you.